This is Clive Neal, who will be talking about targeted sample return using global data sets. Clive, thank you very much, and take it away.
Brad sent me an email asking me to participate in this, and if we go to the next slide, please. After reading his email, I noticed he wanted a completely different talk to the one that I was putting together. So when all else fails, I did read the instructions, Brad. So he also sent me a list of questions that he wanted me to comment on with regards to lunar science questions being addressed by sampling at the Moon's South Pole. Next slide. So this is the outcome from the Lunar Science for Land Admissions workshop we had a couple of years ago at NASA Ames, where we can use the global data sets to actually pinpoint areas on the moon for targeted sample return to address important scientific questions. For example, the potential presence of mantle material, whatever that may be, targeting olivine spinel-rich areas of the moon, young volcanics, the felsic igneous constructs that we now know to be present. These can all be constructed, but what I want to do is to focus in, next slide please, on the southern hemisphere of the moon, because if we are going back to the South Pole, we have a number of science opportunities. Now, this is a slide I showed back in May, and the opportunities you can see listed in the white type there, the lunar environment, volatile deposits, feldspathic highlands terrain, far side materials, due to impacts putting the material at the South Pole, studying the impact process itself, geophysics, sample return. There's a lot of opportunities for lunar science at the South Pole. An important thing to remember is we're now in a distinct terrain from the Apollo sites. This is going to be pretty much free from PKT influence, except from samples put there by the impact process. Access to the far side, again, through the impact process, we may have those materials at the South Pole. And of course, location of the volatile deposits, which we've already heard a little bit about. Let's go to the next slide. So if we then look at that, those near side and far side maps and home in on the southern part of that, we can do a number of important, or address a number of important science issues here. The feldspathic highlands terrain, and you can see in the near side highlands, far side highlands plot from the Kagura data that there is a distinction there, and the lunar meteorites are actually starting to show that distinction. So this is something we can test because we are now in a purely feldspathic highlands terrain. Impact melts. You can see, for example, in the top left, the Tycho rays extend down into the South Polar region. We've also got Orientali on the top right figure, but then we've got craters such as Shackleton down there as well, and SPA. So I'm expecting to see impact melts returned from at least from regolith samples that could be quite informative, as well as basaltic samples from the far side that could be very useful in understanding Mare magmatism through that thickened crust or in the SPA basin. And then, of course, the ice-rich regolith again. We're right there. Getting access to some of the deeper craters is going to be challenging, and or maybe even impossible. We don't know. But again, until we can figure that out, that represents a high priority science target. Next slide, please. So I want to make the caveat here that I don't work from NASA, but I had to turn everything into a PDF. So you're going to get lots of words on each slide with no transitions. So I'm going to go through in the last half of this talk addressing the specific questions that Brad set up for me. What are the science questions and priorities for sampling? And I put some down here just to sort of address the areas and the types of samples I'm expecting. Are the highlands materials at the South Pole of the Moon different from those in the Apollo collection? Do we actually see more magnesian, Pharoan and orthosites? And again, if assuming impact melt samples are present, there's an issue here of how do we then assign them to impact craters. So there's going to be quite a forensic analysis in order to do that. And will we ever be able to do that with complete confidence? Is there a compositional dichotomy between near side and far side basaltic materials? And then what are the origins of the polar ice deposits? And again, cryogenic sample return. And I put question mark there because we'll get onto that in a little bit. And what are the exploration priorities for sampling? Again, polar ice deposits come front and center here. What are the impurities and how are they distributed? Geotechnical properties of the lunar regolith to inform Artemis base camp plans. So I'm hoping that we have kilograms of regolith samples being returned, which would also be useful for science. But the volatile deposits, there was something that came out of Parvati's recap of yesterday that disturbed me a little bit. And I don't know why we should survey and sample volatile deposits well before ASIU. I wasn't in that breakout session, I have to admit, so I'm intrigued to know the justification behind that, and that's one of the questions I've been trying to post. Next slide, please. So we continue with the science questions again. What is the right mix of rock versus regolith versus rake or sieve rock materials versus core samples versus other? Tough question, and I don't know. It depends upon the science, and we can learn from Apollo. I would say that a bulk regolith contingency sample is the first one to collect, so that we have that for both science and exploration. Representative sampling of hand specimen size rocks and larger samples, and we can see examples of that with Big Muley from Apollo 16. And then the core samples, and with the ANXA project ongoing, we know how important those are. And they may take on an added importance for actually testing if these hydrogen suppression zones exist around these deep PSRs, that we may be able to actually get to those volatile deposits without actually going into these rather interesting environments at 40 Kelvin. Rake samples, of course, yes, they're going to be important for gathering and high grading rocklets. And there's going to be a difference from Apollo, again, because of the polar ice sampling. How do we do that? And how do we get those samples back that can be used in the in terrestrial labs? But I think maybe something that needs to be looked at a bit more is what is the balance between spending the money to get the samples back versus in situ analyses. Next slide, please. So again, continuing on, what new field analytical methods should be employed to assist sampling by astronauts? And having listened to Jack Schmidt for a few years now, I put better gloves in there because dexterity would be important. And then the new developments, and I've listed here a NASA Goddard website that actually looks at handheld XRF, LiDAR, and LIBS. But I think one of the important things to remember is that you can Christmas tree your astronaut into inactivity because they've just got too much going on. And that balance in the field of enabling technology versus too much technology needs to be looked at in more detail. And I think, and it has been looked at by the Desert Rats, and I'm sure Dean Epler will chime in. Yeah, I'm good, mate. Next one. Are there curation considerations that will factor in into polar samples? And again, a number of questions. Is cold curation at 40 Kelvin feasible? What about 100 Kelvin? What about 150? And I know JSC is undertaking studies to look at the science that would be affected by these different cold curation methods. But I would put down, it depends upon what the goals of are there. Do we really need cryogenic sample return? But I saw again in one of those breakouts that yes, we do. Next question, next slide. And this should be the last slide. So learn from Apollo in conclusion. The new sample type science goals will dictate sampling strategy and curation requirements. There are new opportunities here that we should grab. And I think the big question Who funds the research on the samples returned by Artemis? We have a very vibrant SMD. Is their budget going to be augmented, or will this be run through the Artemis program? And it's something I think we need to discuss sooner rather than later. Thank you.
Thank you very much, Clive.